Sometimes we'll want to draw text in OpenGL, and there are a few ways we can do this. I'll just mention some of the approaches and give some of their pros and cons. The first approach that we can use is bitmaps, not the kind of bitmaps that are image files that we've seen, but actually a special OpenGL construct, which I haven't shown. And what it is it's a bunch of bitmaps for each character, and each bitmap has 1 bit per pixel. The bit is 1 if the pixel is colored, and 0 if it's transparent, if it's see-through. And each frame will send a bunch of bitmaps for the characters to the graphics card, and the graphics card will take those bitmaps, and it'll bypass all of the 3D stuff, the transformations and scaling, rotations, and it'll just draw those bitmaps directly onto the window. And this approach has a few drawbacks. It's actually not very good. I recommend against it, because it's pretty slow. You have to send a bunch of bitmaps to the graphics card every frame, which is a lot of data to send. And also, the characters don't scale too well. This functionality is available in Glut, so I'll just go online to the documentation where you can find out how exactly to use this functionality in Glut. I'll just search for font and click right here. So we have these two functions for drawing bitmaps in Glut. But again, I recommend against this approach. Another approach that we can use is to have a bunch of textures. And each part of each texture represents a particular character. And we'll map these textures to quadrilaterals in 3D. And some of the pixels will be transparent and the other ones will be white. And I haven't shown you how to do that. But anyway, this approach is pretty fast. Definitely faster than using bitmaps. And it's also more flexible because you can move and position and rotate these characters in 3D. But unfortunately, the characters that you'll be drawing don't scale very well. So if you zoom in too far, they'll start to look pixelated. A third approach that we can use is to draw characters as a bunch of lines. And this is also pretty fast. And the characters will actually scale well. They won't look pixelated when you zoom in. But unfortunately, it'll represent the characters as a perimeter instead of an area, which kind of makes it look worse. And it's also a bit annoying to figure out exactly where the lines should be positioned for each character. The fourth and or actually, you can use these Glut methods right here to do that particular approach. You can look at the documentation. And the fourth and final approach that I'll mention is we can draw each character as a bunch of triangles. And this approach is pretty fast, not as fast as lines or textures. And it scales well, so the characters will not look pixelated when you zoom in, just like with lines. And another thing is you can give each of the characters a particular thickness, so you can actually make them look 3D instead of just flat. But one big drawback is that it's annoying to figure out exactly where to position these triangles, even more annoying than it was with lines. And as I mentioned, it's not as fast as using lines or textures. But it's still a pretty good approach, and that's what we'll be using for this lesson. So I've actually written a lot of this text drawing functionality already. What I did was I went online to blender.org, where I downloaded a 3D modeling program called Blender, which is open source. Then I used the add text feature to add all of the 95 printable ASCII characters into this Blender modeling program. Then I separated them into different models, and I used the decimate tool to make them take up fewer polygons but still look pretty good. Then I gave each character a particular thickness, and I saved them into separate model files. And then I made a program which loaded in all these models and put them into this nice single file using a particular file format that I designed for this program. And each character, the 2D version of each character, has about 40 polygons on average. And since graphics cards can render millions of polygons per second, if we say 1 million polygons per second, then we'll be able to draw about 25,000 characters per second, which is pretty good, but if you're using lots of characters, you won't be able to use this. It'll be too slow. You'll have to use the line-based approach or the texture-based approach. And actually, the speed, 25,000 characters per second, is about what I measured in some tests that I did. So we use this functionality that I made in our program. So I'll just run it. Here it is. We have a square, and on each side of the square is a particular word. So let's look at the source code. We have first a function called compute scale, which will figure out a scaling factor so that the longest of the 4 strings will be 2.6 units long. Our square is 3 by 3, so it's almost as long as the square. So this compute scale function takes the 4 strings that we want to draw, and for each string it calls t3d draw width, which is a function in this text3d.h header file, which has all the text drawing functionality. And it computes the width of each of these strings. We take the maximum width and take 2.6 divided by that width. So then we have the strings down here in this array, and we have the cleanup function, which calls t3d cleanup, which frees all the memory used by this text drawing functionality. Then we have init rendering, which calls t3d init, and that takes care of loading all of the positions of all of the triangles from the file and setting it all up so that we can draw characters. So then we have the draw scene function, which down here at the bottom draws the 4 strings. So it scales appropriately, and it rotates and translates to the correct side of the square. And then using this nice t3d draw 3d function, which takes care of a lot of annoying stuff about positioning characters, it draws the strings. And t3d draw 3d has 5 parameters. You'll notice there are only 4 here. That's because one of them we're just using the default value. Actually, let me show you that. We have here in our header file the prototype for t3d draw 3d, and this 5th parameter right here, at the end of it I have equals 1.5, which means the default value is 1.5, and if you don't specify a value, it'll just use that particular number. So the first parameter is the string that you want to draw. Actually, it can have new line characters, so it can span multiple lines, which is nice. Then the second parameter is the horizontal alignment of the string. So if it's a negative number, it'll be left aligned. If it's 0, it's centered. And if it's positive, then it's right aligned. Then the third parameter is the vertical alignment. So if it's negative, the string will be top aligned. If it's 0, it'll be centered. And if it's positive, then it'll be bottom aligned. And next we have the depth of the font, which is a multiple of the height of the font. And we want this to be 0.2. After that is the parameter indicating the height of each line. So it'll basically tell us the spacing between the different lines. And again, that's a multiple of the height of the font. And that's our t3d draw 3d function. Actually, I have a function called t3d draw 2d, which is the same idea, only it draws a character without any thickness. So it's faster because there are fewer polygons, but it's not 3D, it's just flat. And that's what we have in draw scene. Just one more thing, down here at the bottom, we have our call to compute scale, which computes the appropriate scale and puts it in this variable called scale. And that's how we draw text using triangles with this special functionality that I made. And that gives you an idea of some different ways that you can draw text in OpenGL.